What is going on, everybody? It's Mr. Uzi here, and in today's video I'm going to show you how to overclock your CPU. For this demonstration I'm using an AMD FX8320 with a Gigabyte 970A UD3. Basically, some things that you want to know if you're going to be overclocking your CPU are, one, is the hardware capable of it, meaning is your CPU unlocked, and is your motherboard capable of overclocking via the multiplier, via the base clock is not a very, I guess it's not as efficient as it used to be. Usually the multiplier is the best way to overclock now. It's the easiest way. Do you have adequate cooling? Is that you have a stock cooler? If you do, you probably shouldn't attempt to overclock. Things like that. And we're just going to go through kind of the process and the methodology that I use to overclock my CPUs, and just some of the software that I use that includes monitoring and benchmarking. So since we're already here at the desktop, let's just go through some of the software that I'm going to be using. So first up, we have CPU-Z, which kind of just tells you the specs of your CPU, what the clock speed is, the voltage, and all that kind of CPU you're running. So right here we have the FX8320. Right now it is at, I think it's at 1.36 volts. And then if I shake this around a little bit, see if we can get the clock speed, it's at 4.3 gigahertz, and the hyper transport link is at 2400 megahertz, and the multiplier is at 21.5. So this is what I had the overclock at originally. I'm going to go for a little bit more, but I'm going to show you how to do that in the process. Another program that you probably want is Prime 95, which is kind of the stress testing program. And I'll leave links in the description where you can find all these programs if you want to do this yourself. And then let's go to the last one. The one of them is not really on here. It's Geekbench, which I do have on the computer, which is kind of just to test the CPU power. And then if you're doing something like video editing, we also have Cinebench up here. And then the last one for monitoring temperatures and voltage, we have Hardware Info, which will give you a nice breakdown of pretty much your entire computer and what all the components are like, temperatures, voltage, all that good stuff. So let me just give you kind of a rundown of what it looks like. It loads up, it's scanning all of the hardware. So we have all of our cores, all of our core voltage. So you can see we're at 1.363 volts. Voltage readings may not be accurate because it's really hard to read them directly from the motherboard in software. So usually if you have the voltage set in your BIOS, which we'll be heading into pretty soon, so usually voltage readings aren't the best to read through software, but once you dial it in the BIOS and you have load line calibration on, it usually fluctuates around that kind of voltage that you set in. With Gigabyte motherboards, this is using an analog version of it, it's not digital, so the increments are a little bit higher than what you would get on a digital based VRM solution. And that's another thing I wanted to add in, is that when I said power, a lot of motherboards, especially if you're not using, for AMD at least, if you're not using the 970 chipset and above, like the 990 and 990FX, you're probably going to see a lot of motherboards with lower power delivery systems, so maybe 4+2, whereas you're probably going to want something like an 8+2, like on the Gigabyte 970 UD3, or even more. I think that goes up to 10+2 on the 990FX boards for those high power, or those power hungry AMD CPUs like the 8350, 8320, and I guess the 9590 and 937. All that stuff, that's just kind of not recommended. But just make sure that you have enough power for your motherboard to deliver, and also check your power supply to make sure you have enough power so that you know that you'll be able to power the entire system, and that if it shuts down, you'll know that maybe you don't have the right power supply and it's not able to give it enough juice. So this is just the basic rundown. Right now we have it idling at 23.4 degrees Celsius right now, and it was a maximum of 33. I did turn the fans off on my computer right now just because the noise is kind of, it's really loud. I don't have the quietest fans on here, but I will turn them on when we start doing stress testing, just to, be able to keep it cool under a normal scenario. So without any further ado, let's head into the BIOS, and we are going to look at what kind of settings you're going to see in there and what you're able to tweak in order to get the overclock that you want, as well as some methodology as to how you overclock. And there's a couple different methods. Now this motherboard doesn't have a UEFI BIOS, so I still have to use the keyboard to maneuver around it, but let's just go through some of these menus and kind of just what they're all about. So on the top, which is pretty much the most important menu for Gigabyte motherboards, is the MB Intelligent Tweaker, MIT. Nice school, I didn't get accepted to it. But MIT, so if we go into here, this is basically where you're going to see all of your overclocking settings for your CPU. So you have your clock ratio, North Bridge, core performance if you want to do something like turbo boost, frequency, PCI stuff, you don't really have to worry about this. The hypertransport linked width and stuff like that, you could probably keep that at stock. You have your settings for your RAM. If you're running 1600 megahertz RAM or higher, you might have to dial in a specific profile to make it run at that rated speed. And then down here, you have your voltages for all of your components. So right now, my voltage is set to, it's 1.3875 for the voltage. It was a little bit higher than I had said earlier. And that's really just one voltage bump up. Now, when it comes to overclocking, there's a couple different methods that you can do. You can stay at stock voltage and overclock it as far as you would like, while keeping or maintaining that stock voltage. So if you're not really looking for a really high overclock, but you want to just get the most juice out of your CPU without having to, up the power, up the voltage a whole lot, that's one method. Or you can go to the maximum, I guess, safe voltage you would like to stay at, and dial that in, and then just ramp up the CPU clock speed until you find something that kind of just sticks. So I've already done the kind of just stay at stock voltage or somewhere around there, and I got around 4.3 gigahertz out of it. It was stable at pretty much stock for most uses, but in stress testing, after about 10 minutes or so, it would drop out. So I decided to just up the voltage a little bit, and it's been stable since then. But we're going to go with the more aggressive method in kind of just upping the voltage to something, a little more aggressive, and seeing how far we can ramp up the CPU clock speed. So let's go ahead and we're going to change the CPU voltage. Let's see if we can get it to 1.48, 1.4. This seems like a good 1.43. Might be a little high, but we can always dial it down if it's too much, if it's more than we need. And right now we have the CPU at 4.3 gigahertz. Let's go back down. Let's put this back down to 2200 because I upped it a little bit. And we're going to go into clock ratio. Right now it's at 4.3. Let's see if we can go to, let's try 4. Just go 4.8. Just throw it against the wall, hope it sticks. And then let's go back and we'll show you the other menus. Excuse me. Standard CMOS is kind of just like your hard drives and stuff like that, and I guess you have IDE and stuff like that. If you go into advanced BIOS settings, you have load line control, your C1 states. So I guess I can disable C6 so that it stays at that higher clock speed in the C1E. Cool and quiet, I will keep that on. And then you have your core control and all that stuff, and all of your boot settings and all that stuff below it. And you have integrated peripherals. There's nothing really interesting in there. It's just kind of all of your different ports, SATA, stuff like that. Power management, kind of just setting like different, I guess, just monitoring different things and how you boot and what different functions or what different buttons on your computer are going to do. And then PC health stats, which is actually kind of a helpful one, which shows you your dialed in voltage pretty much at this point, pretty much your entire system, and it gives you a temperature of that, and it kind of gives you like warning temperatures and fans, fail safes and warnings and all that good stuff. So usually I just keep CPU smart fan control on, and the other ones I just keep off because they don't have temperature controlled. They're all voltage based. So right now we have a CPU temperature of 40, and it says a system temperature of 36 degrees, which is pretty good for now. We are using the Hyper 212 EVO or 212 Plus, and right now the fans are off, so that might be why the temperature is a little bit higher than normal. So we have all our settings dialed in. Let's go back in and just kind of show you what they are again. We're at 4.8 gigahertz, and I just upped the voltage to about 1.43, which is, it's kind of high, but usually these CPUs are rated to up to 1.5 at the highest, and I can always dial this back if I don't need this much voltage. So let's go ahead and reboot into Windows. So let's go F10 to save it, and that's usually the same for most motherboards. And it'll start to reboot now. Shouldn't take too long. There's an SSD in here. Should go through all of my drives. So far so good, as we've made it through. Looks like it's booting into the operating system. It hasn't shut down yet, which means it has just enough juice or enough voltage to push that 4.8 gigahertz clock speed. The CPU fan is kicking up a little bit. It might get a little loud. I am going to turn on the fan just so it doesn't shut off on me like thermal throttling. So you might hear a little bit of wind rushing through here. So let's go ahead and log in. Alright, so usually the first thing that I do when I'm doing kind of overclocking is I head into hardware info, open that up and let that run. and just kind of keep, oh, there we go, we got a blue screen. So it looks like we just don't, it's not stable as of right now. So we're gonna go and we're gonna lower the clock speed. It looks like I think I put it at 4.8 isn't going to work with this. So let's go back in, mash the delete key until we get into the BIOS once again. So this is kind of a tedious process if you don't necessarily get the right clock speeds and everything set. You may have to restart your computer multiple times, and then once you get it kind of stable where you can start stress testing, it starts to add a little bit to the process. So let's go back into MIT, and we're going to lower this to 4.7 and save that, and we're going to head back into the computer and see if we can boot and run the stress testing program at Prime 95 to see if we can actually use this as kind of a daily overclock. And then we'll also, look at things like temperature, and once all of this is stable, if we can get it to a stable place, we will do some benchmarks and see what kind of performance we're getting. And I believe I do have stock benchmarks. If not, I'll run those again. So we're back at the home screen. Let's log in. All right, so we are at 1.4375 volts, I believe is what I set it to. It's taking a little bit longer than usual to load into the okay, the desktop loads up. All of our icons are there. Yeah, the Hyper 212 is necessarily the most efficient cooling solution, especially for an AMD FX CPU, so I can definitely hear it spinning up quite a bit. But let's just, let's go for broke. Let's go into hardware info. I always like to look at what idle temperatures are before we even start any stress testing. If they're already too high, then there's really no point because you might be damaging your CPU. So it looks like it's already, okay, so we're at 4.7 and it looks like our voltage is at 1.36. I'm surprised because I thought I said it's 1.4. This is why voltage readings in software aren't necessarily the most accurate. So it looks like we're idling at about 30. Oh, it's going up. So looks like it ramped up just a little bit, but we're idling, I'll call it 30-ish degrees, give or take a couple degrees. So it looks like we're well within our stable or comfortable temperatures for an idle system. Nothing's really running right now. So let's go ahead. Looks like it's creeping up a little bit, and we're going to jump into Prime 95. And we're just going to do small FFTs, and this is basically going to run just a cycle of pretty much just crunching numbers on the CPUs and seeing if they're stable. I personally don't think it's going to be too stable. I think I'm going to see a lot of cores already drop out pretty soon, but so far so good. Let's have a hardware monitor up here, and so far nothing has dropped out. Oh, one core has already dropped out, worker number 7. So, I mean, there's really no point in letting it run anymore. We're just going to stop it here because it is not stable. So let's just go up to test and stop. And like I said earlier, this is probably going to be the point where I cut a lot of stuff because it's going to take a few tries back and forth to get a stable overclock. I may need to up the voltage. I may need to lower the clock speed. So I'm going to cut it here, and I will be back with the final overclock stable, and then we'll go into some benchmarking and see how that compares to maybe a stock CPU. Alright, what is going on, everybody? I am back. I did some benchmarking for somewhere around maybe like 45 minutes or so, and I got a stable overclock. I had to dial it back to the stock settings because I wanted to get the kind of the baseline baseline benchmarks so you can compare them. So I was at 4.6 gigahertz. I disabled core performance boost, which is the turbo boost. Let's go back up to 2400 for the hyper transport, and then voltage was that's interesting. I had it at 1.362, but voltage was at 4375, and that's very interesting. The voltage actually went up. The normal voltage went up higher than usual. All right, and then we will go back into PC health status. At stock, it was really cool, very chill-like. Temperatures are really low. But now let's head back into the operating system with this dialed in overclock. I ran Prime 95 for roughly 15 minutes with no issues. It ran smoothly, went through I think 4 passes, so everything seemed to be fine. I'm still kind of wondering why the normal voltage has changed. But yep, let's head back into Windows, and I have my stock benchmarks here on a piece of paper that is wrote down. I only did 2. I only went through Geekbench 3 and Cinebench R15. So just overall CPU performance, and then if you're doing something like video or photo editing kind of stuff like that, you can kind of see what the performance is going to be like. First up, we are going to run Geekbench because it is the shorter of the two. So let's go Geekbench 3. This is only the 32-bit version. I don't have the 64-bit version, but it shouldn't make that much of a difference, so let's do later. And we're going to run this benchmark. Looks like it's going to spit out a number now. So after the overclocked, single core score went up to 2405, which is an increase of 400, which is about 25% or so increase. And then the multi-core score went up to 11,649. Not really sure what the math is on that one for performance increases, but if you look on the screen, I did a couple of benchmarks previously, but so this one is the most recent one, 2010 10,040, 1933 10,177. So there's a pretty big difference in single core performance. It's about 25%, which makes sense because it was overclocked about 1 gigahertz over, so from 3.5 to 4.6. So it's in the realm of, that's where it's supposed to be. Multi-core went up by, 1600 or so, which is still, as again, it's pretty good. So let's head into Cinebench, and we will see what the difference is there. So let me see. All right, so let's go ahead and run the CPU test. Alright, so now as this is rounding out, we're finishing up this test. One thing that I do want you guys to pay attention to, there are a lot of people who say that, Intel's better than AMD or AMD is, bad or whatever. But just looking at the scores for the rankings of the Cinebench, I know these may not be updated or whatever, but with this overclocked FX 8320 at 4.6 gigahertz, we are competing with the likes of the i7 3770. As far as overall performance, so single core came in at 108.6 or 108 for single core, so that gave it a multiplier of 6.25. So that was actually a little bit lower than the single core, which came in at 6.35 for the multiplier. But then that again will vary from test to test. So if we go to the overall CPU performance and we look at it, the FX 8320 at 4.6 gigahertz is beating the i7 3770, right? Now the FX 8320 can be got for, $130, whereas the i7 3770 is 200, 250 plus, or if you want to do the 4770, you're probably going to get up into the, $300 range. But even the 4770K overclocked at, overclocked to 4.4 gigahertz is 150 points ahead, but it's almost 3 times the price of the CPU. So yes, it is faster, but it's significantly more expensive. If you're going for the fastest of the fastest CPUs, just get an Intel, go X99 or something like that. But if you're just looking to get the most money out of your purchase, FX CPUs are not that bad. So there are our benchmarks. So let me crunch some numbers really fast just to give you percentage breakdowns of, increase in performance, if Chrome will open up or wants to open up, or we'll just go calculator. All right, so for Geekbench 3, for single core, we went up from 2010, so let's go 20 to 2490 2490, I believe. 2490 minus 2010 divided by 2010, which is a 23.8% increase in performance for single core, and then I believe 11246 minus 10,040 divided by 10,040, 12% increase in overall CPU performance when all of the cores are being used. And then for Geekbench, we went from 678 minus 533 divided by 533, 27% increase in performance. And then single core kind of varies between tests, but it did go up by about 20% from 87 to 108. So you're seeing about a 25%. It's scaled pretty well as far as performance goes. This is a very easy overclock to achieve. 4.6 gigahertz at 1.42 or 1.428 volts is not, anything ridiculous. If I really wanted to, if I had better cooling, I could push this maybe up to 5 gigahertz if I really wanted to. The voltage would get high, but I would definitely be, I could cool it better and it would get a lot faster. So this is kind of just the overall guide of overclocking. Is it worth it? In some people's eyes. But if you do want to do it, it is free performance. You don't have to pay anything to get it. All you need to do is make sure your hardware supports it. And that's really all I have for you guys. If you like this video, hit the thumbs up button. If you didn't, hit the thumbs down button. If I missed anything or if you have any questions just to clarify what I did or how I did something, please leave a comment down below in the description. Anyway, thanks for watching, and I will see you guys in the next video.